Alright, we'll now go on to question 3. This is on heat, so take some time to read the question first. Alright, so this question actually says that William conducts an experiment to find out the heat conductivity of 4 pots made of different material. So we have pots A, B, C, and D, each made of different materials. So he poured an equal amount of tap water into the 4 pots and placed them under the sun in the same place. So what's going to happen is, after 20 minutes, William will record the temperature of water in all 4 pots and is shown in the table below. So over here, the starting temperature of the water is recorded, and actually all have the same starting temperature at 25 degrees Celsius. But after 15 minutes, the temperature was recorded again, and this is what he observed. In A, it is 29 degrees Celsius, B, 38 degrees Celsius, C, 26 degrees Celsius, and D, 35 degrees Celsius. So, which one is made up of the best conductor of heat, and which pot is made of the poorest conductor of heat? So, we recall best conductor of heat is able to allow heat to travel through it faster. So, because it allows heat to travel through it faster, it will definitely get warm at a quicker time. So over here, this 38 degrees Celsius temperature actually shows the best conductor of heat. And the one with the lowest temperature, which is in this case 26, is actually the poorest conductor of heat. So if we were to arrange these temperatures from the lowest to the highest, we will be able to arrange the pots in order of poorest to the best conductor of heat. So the correct answer should be C, A, D, B. C, A, D, B. And the best answer would be 3. So let's move on to question 4. Take some time to read the question first. Alright, so you have 2 containers here, each with 150 ml of water at different temperature. So beaker A shows 50 degrees Celsius, while beaker B shows 20 degrees Celsius. So what's going to happen is they're going to pour water from A, all of it into beaker B. And we're going to ask, what is the change in the temperature of water for all the water in beaker B? So as we all recall, heat falls from a higher temperature to a lower temperature. So since the water in beaker A has a higher temperature at 50 degrees Celsius, the heat's going to flow from this 50 degrees Celsius to 20 degrees Celsius. So this means that the water in beaker B is going to heat up slowly over time. So therefore the temperature should increase. So let's look at the graph below. So if we look at this graph, we realize that all actually shows an increasing trend because all the graph shows it's going upwards. But the temperature at which it ends is important to tell us which is the best suited graph. So let's go back and look at the temperature of beaker A. So the temperature of beaker A is 50 degrees, which means that if we were to mix beaker A and B together, the highest temperature it can record should not exceed 50 degrees because heat only travels from a hotter to a cooler region. It is unable to heat up above 50 degrees if we do not have a heat source. So since there's no mentioning of heat source in this question, we cannot assume that. So therefore, B and A are out because the temperature at which it ends above 50 degrees Celsius. So let's look at C and D. D remains at a constant 20 degrees, which shows that there is no change in temperature. So this answer is also wrong. So by elimination, we will be able to deduce that the best answer is actually 30 degrees Celsius with the option of number 3.